Thank you. We want to thank you for coming to this panel. There are a lot of presentations in this Congress, so thank you for choosing this session. I want to thank José and Paulo, who will make the presentations. Paulo, who couldn't make it here, couldn't come to Argentina, so he will make a presentation by Zoom. We will be presenting one of the last presentations on integrated crop livestock production system. I don't know if you have been present in other sessions on this topic. Really, this is a defining topic in agricultural companies. Integrated systems are far more complex than a crop system or a livestock system, purely livestock or purely crop system. It's more complex because we have more people working, more suppliers, more services coming in and out. And this side of human resources is the weak point in these systems. Those who have participated in a crop livestock system, you can have great technology, but if you don't have the team to use these technology, we will probably fail. So we have two objectives for this session. Paulo Carvalho he will tell us how to go about human resources in this integrated systems. When you are in the farm, you think of an organizational chart to work with a crop livestock system. What's the size? What will be the structure? Will I have one or two agronomists, one or two veterinarians, the foremen in the farm, the staff or workers, many suppliers? They did a very good job with farmers from Brazil and France. So they tried to figure what is the profile of the staff that we need to go ahead with an integrated system. Paulo is responsible for one of the most important groups globally. They have achieved a systemic structure. He's attending the fourth Congress, the fourth Aapresid Congress. And another objective, as we did in yesterday's dairy panel, we wanted to present to you José Jáuregui. He is a professor in the university. He works with Datamax in Argentina. He will speak about the challenges of an integrated systems, and he will share examples of Argentine systems. And also, he can speak as a farmer because they have their own experience about this integrated system. You generally don't hear much about this kind of topic. Paulo, are you ready? Are you on? You can start, Pablo. Hello, Pablo. Good afternoon, everybody. I apologize for not being with you this afternoon. Really, I had some personal family problems, At least I can connect this way. I first want to thank you for this invitation. I'm really glad to share this topic with you. Keys in the management of an integrated crop livestock systems. I have 20 minutes. I will focus on two main keys that have to do more with the stuff, with the human resources. How does the farmer think about this? The farmers have a sort of compartment view or divided view of the systems. And they have to work with consultants who are experts on specific components. There are some people that have a general view, a more holistic view of the system. I want to share with you our experience in a few minutes, experiencing developing tools to work on these important items that have to do with people involved in integrated systems and the tools that we are developing to improve the adoption of integrated systems and the decision-making process. This is a global view of the trends. Integrated systems are dominant in the production systems around the world. It's 2.5 billion hectares of integrated systems globally. We made a survey, we conducted a survey with people from different countries. We can see that Brazil and Argentina has a significant share of sites working with integrated systems. But this is not the global trend. After the Green Revolution, and most of the countries have undergone a sort of disconnection between cropping and livestock. It's important to make a difference between intensification and specialization, because the problem is not intensification. But there are problems in the specialization when diversity is lost in the crop livestock systems. The problem is to bring something to the same or to have something in a uniform level, but diversity is lost. This has a negative effect on the environment. And these effects are more frequently reported in literature globally. Mostly in relation to the biogeochemical cycles, in particular nitrogen and phosphorus cycles, which shows that production systems are simplified in terms of diversity and simplified in terms of inputs. These pictures are a good example. These are rice paddy fields in Japan and in Brazil. The climate is quite different, but the systems are very similar. But the climate conditions are different. This is a result of more intensive systems, but specialized systems that produce a commodity, as is the case of rice. They produce only one commodity because they are so specialized that all the processes are similar. The global trend is not integrating, but rather specializing. But specialization with diversity laws have evident consequences, bring about many problems. And there are research groups, expert groups. There are some governments even that are trying to reconnect the crop and livestock systems in Brazil, for example, is one of these countries. They are working for many years now, since 2010, they are implemented programs focusing on integrated systems. This increases in Brazil by 1 million hectares per year, but this is not the trend around the world. This is a trend that also appears in production and research and in education. This is what happens in Brazil. It might be similar in Argentina. If you look at the supply of curricula on federal integrated systems, only 10% of universities are offering this topic in their curricula. In postgraduate courses, this might represent 20%, but in the academy, this is not part of the general education idea, and this brings about consequences in terms of human resources, because we don't have enough people trained with the more general or holistic vision of the systems. These systems have a number of benefits and synergies that are clearly reported in publications, science publications, and in technical publications. There are clear benefits in the structure and use of the resources in the sites. Also, there is diversity. This is a great benefit, having diversification. It means financial and biological benefits. There are many benefits, but these systems are more complex. And but really they are against the trend. This is not the trend. And there are many challenges, different challenges. But today I want to focus on human capital as a challenge, just to illustrate and by way of example of this challenge, I will present a paper, a work that we did some years ago on the profile of farmers that adopt integrated systems. It's interesting to note that farmers show are less willing to adopt integrated system, less willing than the livestock breeders. This is a challenge, but this can give the possibility to put in place public policies or financial investment. Another interesting thing is that corn growers had lower probability to integrate. And also the same happens with farmers older than 60 years. Farmers that are more already specialized with up to 2 agricultural crops, they have lower chances to adopt integrated crop livestock systems. And this probability is increased, or the probability increase as bigger the site is. Increase the bigger the site is, because these bigger sites have more staff, and this involves the social side of adoption. In Brazil, we have 2 situations. In the central region of Brazil, the crop systems are integrated to livestock systems. This is a way to recover degraded pastures. The statistics tell us that in central Brazil, we have 40 million hectares that are significantly degraded by overgrazing. And because there's lack of fertilization, where soybean is mainly planted. And in order to recover the soil, they plant pastures after the soybean. Then we also have farmers that don't use the winter grain of wheat. Wheat is not an option. 1 every 5 farmers plant cover crops with oats or with ryegrass, and they use grazing, and in this case they have possibilities to implement livestock systems.
But this, as I've already shown, are different processes and different systems. Obviously, those systems are much more complex, and if they're more complex because of the soil, the animals, the plants, all the financial and economic part changes too. The structure, the number of staff, workers, supervisors. These systems are more complex, and this requires more knowledge, more tools to work on these more complex systems. Some systems are more specialized, There are some farmers who only do cattle breeding, others only do agriculture, and they have a different approach. The challenge when you transition to more complex systems is to integrate this, and in order to do this, you need to have a more systemic vision, or a drone vision, as we say it. It's a more open, top-down vision. Whether it's farmers, technical people, or students who will eventually become consultants, well, we work on a methodology to go through different stages in the transition, which is a change mindset. When you go from specialized systems whose operation is simpler and decision-making is less complex, there are fewer factors to be managed, and there are different actions and workshops where we break down the specialized processes and we try to contribute knowledge about concepts and tools so that growers can go from this mindset to a new way of thinking and designing production systems that are not in silos but which are interrelated. All components are managed in a single systemic way, including the planning. In this deconstruction and construction process, there is a step, a significant one, where we use a tool that we call serious game. It's a serious game, actually, where students, technical people, farmers live an experience about planning these more complex systems. Obviously, I do not have time to get into more detail, but you will find all the reference information on my slides. But there is an operation model where farmers, technical people, and students can learn and see the consequences of their decisions regarding types of crops, types of pasture, crop livestock systems. They can see the consequences in time and on space. It's like cards that workshop participants can choose, and their decisions have consequences, and every posted here, every one of these is 1 year of planning. You see the consequences of rotation. And these consequences also affect the profits. There are also biological consequences, economic consequences. Again, there's not enough time to go into detail, but there is a sequence. There are stages where we build on the idea on how to work with these more complex systems. How can we think livestock and agriculture together? Because usually farmers, technical people, students tend to like one more than the other, or they do not think of both things as a system. This is one part of the process. where we use this tool, which helps them a lot in this mindset change process. Obviously, this is a major problem in Brazil. I guess it's a general problem. As Leandro says, we also participated in studies in France and the US, and everyone has the same problem. They have technical people that do not have this vision. In general terms, this specialization process and human resource training process can be seen all over the world. So having advisors with a more holistic view is quite rare. This is almost a joke, but it's true at the same time. These people are superheroes because they need to know about grain production, trees, livestock. They need to have an open and general view, and they need to be able to coordinate the various components in the system. And they also need to have empathy so as to be able to work with the landowner, but also with those who eventually manage the system. I assume you have the same situation in Argentina than the one we have here in Brazil. The technical people are farmers or growers, but very rarely do we find people who can go back and forth between both systems. This is something that we have to focus on in the academic sector. We need professors to teach this. This is why this is a superhero, super person, super technical person. And coordinating all these systems at the same time, the biological components, the personal components, the farmers, of course, the workers, people driving the tractors, those who build the fences, well, everyone. It is necessary to coordinate all processes which are sometimes antagonic, even when you have farming and livestock. They usually are antagonists or enemies, so coordinating all this work and have the necessary empathy to do some counseling with workers, their relatives, to be a kind of facilitator. This is why integrated system advisors are difficult to be found. It's difficult to find the superheroes who have all the necessary characteristics to work and be part of a system that is undoubtedly complex. And this is the trend in agribusiness. Well, this is what we are working on. We are developing tools, ways to work on different systems, soybean, corn, livestock, grazing, livestock. There are more complicated systems related to more formal processes and procedures, contracts, and the like. So it is key to have the necessary technical people with the right license. Unfortunately, it is difficult to find these people, but here we are still working on developing tools, as I've already shown, and trying to create subjects and courses on these topics, courses on more generalistic and cross-sectional topics so as to educate technical people who have a systemic perspective. An example of a group of technical people whom we trained and who worked with 34 farmers here in Brazil for many years. This is the consequence of sustainability assessment about the environment, governance, economic aspects, and the social aspects, with very good positives, and light green and dark green, that's the best. And there is also a systemic assessment, quite complex, or quite complete and comprehensive. And this score is not very good. It shows how agrochemicals are used. But except for this, in general terms, the scores are very good as a result of good work in a system that brings benefits and synergies as compared to more specialized systems. We had some meetings with farmers, and the final stage was a workshop. Usually we spend 3 days with farmers. With students, it's throughout the semester. But here, we have workshops with farmers who want to transition to integrated systems, believing in science, believing in research. This is fundamental. This is what some growers said. You have to be humble enough to change your system. In this respect, the advisor is responsible for bringing the necessary knowledge. And by bringing knowledge, that person also integrates university into the operations. Knowledge equals progress. To conclude, so as to finish on time, I was given 30 minutes. Well, the integrated crop livestock system is more complex, and there are some key aspects to be taken into account in terms of mindset, attitudes. This is very, very important, and advisors are very important too. We are now reconciling agriculture and nature, because we are confident that the future production systems, or at least part of them, will have to be reconciled, because those systems have more ecosystemic system production as compared to specialized low diversity systems. Today, we are participating in 2 major projects, the PISA project and the ILP project. The PISA project is with cows and The ILP is a project where we're developing applications at the site level. To conclude, we have to choose the way to go. Many people are going towards the more specialized, simpler systems, but there is a consequence there in terms of sustainability. Integrated systems are more complicated. There will not be so many people on this journey, but it's a longer-term journey with many more benefits and synergies. So you have to choose. These are personal decisions, even when we're studying, when we are teaching, when we're doing research. We have to make decisions. My pill, I've already chosen my pill. I've started my journey with few people, but I feel confident that it's the right way to go. Well, these were the ideas I wanted to share with you. Thank you for the opportunity, for the invitation, and we'll stay in touch. Thank you. Thank you, Paulo. We'll now listen to José's presentation, and if there's time, we will answer questions. We'll have a Q&A period. Where can I stand? Can I move? Well, I was very optimistic with times as usual, so I'll have to go faster. Opportunities and challenges of traveling in time. Integrated systems, strictly talking, are very old systems. Animals used to be part of many agricultural systems from very early times, the Egyptians. If you go back in time, these are images taken from the National U.S. Library. They're very good old images. This is 1942, cows eating stubble. So they were participating in a wheat crop. And if we look forward, we can go to the province of Buenos Aires. This picture was taken on February 2020 with animals grazing on stubble. So this is not a new phenomena, but it's part of something that's very good and that Paulo mentioned. We have become very specialized, and now we are starting to go backwards to attach new value to animals, especially ruminants, but others as well. What I'm going to say is quite basic, but what is an integrated system? I think we all know this, but I can summarize it this way. 1 + 1 is more than 2. So the whole is more than the addition of the different components. For example, the residues of agricultural production are getting or are becoming more valuable. There is a brief summary here. How do they interact? Interaction between a farmer and the agricultural system that generates some residues, not only for animals, but it's also part of the food for the soil. And sometimes we have to supply some byproducts, and the system will also contribute something to our system through the feces, urine, stepping, and for the recycling of some nutrients, although we will see that there are some difficulties there too. This obviously generates different types of releases in both systems. We can also talk about beef, milk, hide, and other products. I think this has already been mentioned in one of the presentations. It's a foodscape concept. The integration of agriculture and livestock has a lot about this. This term is starting to be used a lot, and I think it's valuable because it includes the social part too, so that society will think it's okay for the animals to go back to environments where they're not present today. This is a nice example of a foodscape. This is a picture I found earlier today when I was trying to see what we had in terms of foodscape. This is a vineyard combining animal production too. We can see the sheep there. The sheep are grazing not only inside the vineyard but outside as well. And they integrate everything besides integrating tourism as well. So they do wine, beef, and tourism. And this is part of the foodscape, something that is nice to be seen and that provides food at the same time. And there are 4 examples here. There are many more, but this is a typical example we've already seen, the integration of a crop-livestock system. The animals go into this area during some time of the year to eat stubble, but the rest of the year they are somewhere else. This is a more integrated system. This is some land in Entre Rios with pasture rotation. We're seeing alfalfa there, and at some point in time there will also be grain there. And we've already seen the vineyard. This is very interesting because the sheep not only contributes beef and meat and helps us control some weeds, but if you burn grass, this is also dangerous, but there are some sheep species that cannot stand on 2 feet, so some species are selected so they will not graze, so to speak, the upper parts of the vineyard. They eat only the grass, the lower part, and this stimulates vineyard production. So there's a very interesting synergy there and a very good combination.
These are pictures from Brazil. These are forest grazing systems. The streets have been implanted, but we can talk from livestock in forestry. Much progress has been done. Today we talk about return of investment, how long will it take to recover our investment. Livestock can help us overcome this first period before we have the return. One important critical benefit has to do resilience for climate change. We start to mitigate some risk. It's not the same to have 1 or 2 crops than having several crops, and that having also livestock. There are less possibilities for failure. We will have less variability of production. So this is one of the strategies that we have today with climate change. Another thing is control of ponding. We see here a field with green fields most of the year, and on the other side we have fallow fields. Noceto and other authors made a very interesting research. They mentioned the control of ponding. We have a green system that is transpiring most of the year. It is eliminating the water, and here we can see what happened when we have monoculture systems or 2 crop systems. They consume more water but not as much. And so this has to do with facing ordinary or extraordinary climate events. We always talk about carbon capture, carbon sequestration. This is work of Stewart in Balcarce. They start with 3.54% of organic matter, and then they end up with about 3% when 1 crop is planted continuously. See what happens with that experiment after 8 years. includes a pasture. The soils of the Pampa region have about 50% of capturing capacity. So with livestock, we have the possibility to increase organic carbon even in agricultural soils, in cropping soils. One of the most interesting that we have in the region, Uruguay have been 60 years measuring carbon in soil, and with a perennial resource, we will find a reduction in soil organic matter. These are more complicated soils, more complex. When we have pastures in the rotation of 50 or 60%, the organic matter level is kept, of course, always depending on climate conditions and the production values that we might have. Another environmental benefits, recirculation of nutrients is controversial. This is an example of recirculation, but also of concentration. Sometimes decoupling of nutrients occur that patches of urine have high nitrogen concentration so that the pasture cannot be used. We have some leaching risks here. But in general terms, in systems with not a high stocking density, we can have specific problems. Literature tells that in optimal conditions with that not excessive soil moisture, we will contribute to improving that soils, and in conditions where we have ponding, the situation is different. In service crop, there are evidence in the increase in growth. This is interesting. Sometimes we talk about how livestock's impact on the following crop. If I have an animal, how will this impact the yield in next crop? This is an analysis of 66 papers that evaluated these topics, and the finding is that there are no differences in the yield of the following crop. And also, there are soils of an intermediate texture. We can find some increase in the yield when we incorporate livestock. Service crops used for grazing. When I worked in Gentos, we participated in a trial of cover crop or service crops. We did some trials with or without grazing. What we found basically is a reduction in the total yield of the service crop, but about 300 to 400 kilos of meat per year in a cycle of 45, 60 days of grazing. The meat production was that. So we thought that the service crop has a cost, but here it does not only provide services, we keep the ecosystemic services, capturing carbon, biological fertilization with nitrogen, and additionally we produce meat. Here we observe significant differences in favor of corn with or without grazing. This is only for 1 year. Probably it's not so definite. But there was no difference in the meta-analysis we saw before. The person who is involved in this is here present in the room. This is El Chañar in Córdoba. I've contacted them for a certain time now when I worked in the other company. Here we talked a lot about the social side. We had the possibility to train the staff on grass management. We worked a lot with that integration. I just want to make a short description. This has this field has 25% of wood, and also it has a mixed system with crops, alfalfa, crop is rotated. It is basically an agriculture, a cropping system, but it includes alfalfa as pasture. And so animals are integrated to this cropping system. Here we see that in red shaded areas have mean that the soils are more complicated. Then we also have the cropping system that includes rotation with alfalfa. Here we see we have woods, we have combined pastures. We did well in some cases, but not that well in other cases. When we made this combination, it sounded interesting, but we explored the possibilities to see what were the blends or the mixtures that worked better. We can see here how, after several years where we are measuring the gross margin, we can see how margins of livestock and cropping systems come together. We worked on improving these processes, and we see how livestock came closer to the deviation in cropping is in livestock plus minus $100 and the deviation for cropping systems is $275. When we started, the system was so good. We broadcasted mixtures on the weeds with clover, and also we tried with grass plants. So this is an interesting strategy. Sometimes it worked better than others, but it's interesting. This is the process from going from the monoculture, then going to cropping rotations, and now they think of integrated system rotating with pastures and then combining with the livestock system. And this becomes more complex. Paulo said this. They become more difficult. These things cannot be easily implemented always, but we start to reduce degradation, we improve characteristics of the soil, and we are able to start working with more sustainable systems. The conclusions, I think that was able to keep the time. I was a little bit fast, but 2 or 3 conclusions. First, integrated systems allow us to increase resilience. We talk a lot about resilience. This is the capacity of a system to come back to its natural condition after some disturbance. Generally, one of the concerns is that the following crop, but we don't see any negative impact on the next crop. But this is what happens in general. Pasture or grazing of service crops helps us keep the environmental services and provide additional products as meat. The advancement of the agricultural frontier did away with the basic infrastructure, including animals in our agricultural systems. It gives us an opportunity. Manpower is a limitation. It's more difficult to hire staff, and we require more manpower. But this can be an opportunity to bring people back to the rural areas. The focus is on the processes. We had been able in agriculture to develop packages with technologies and inputs, and for integrated systems for livestock, this is more complex when we think of developing packages. And my last thought, we have the possibility to turn our farms in productive landscapes or foodscapes, making livestock more attractive. This includes all the environmental and production benefit. Thank you very much.
Hola, hola. Hola, hola. Gracias, José, por el tiempo. Bueno, nos quedan unos minutitos para unas preguntas.
There's some more minutes for questions. Paulo, are you on? This questions addresses directly what is the key to prevent an integrated system to fail? Is the opposite of what I presented. Apart from the technical part, we are always looking at the grazing management. I didn't mention that, but that is an important part of this process, especially in systems where you rent the land. There was also being a sort of dispute between the growers and cattle breeders. Cover crops as pasture are annual pastures. This is a common problem, and this is a factor of a failure, a key for failure. Some people deal the integration as a rotation and not as an integration by itself. They plant 2 crops and not 3 or 4, and this is when people is not open-minded and are not willing to work in synergy. There is a question that probably Paulo can answer. What do you think about including forests in integrated systems? Embrapa in Brazil makes a huge effort with forest components. If integrated systems are complex, they will be more complex with forest. They have not been much studied. They are not very well known. Although there are initiatives from Embrapa, these are less than 3% of integrated systems in Brazil. We need to increase our knowledge on forest components, but we know that they are very complex. Probably this is the reason why they have not been much adopted. But on the other hand, the forests are considered as a stable and sustainable system that would provide more diversity, and probably they would be more similar to natural system, herbs, or with animals that eat herbs and that step on the soil.
This would be very interesting, and it's also important in terms of carbon balance. Trees help a lot to reach a positive balance. The last question, which is related to carbon balance. Here we've talked a lot about carbon footprint, carbon balance, because farmers and growers want to start measuring their carbon balance and take some reference values. And there is a following question. Do you have any experience in measurements in the integrated system as compared to a more specialized system? I mean carbon balance measurements. Do you have any experience in Brazil? Yes, it's a hot topic. And what the example mentioned by José is great. The example of the experience carried out in Colonia, Uruguay. They will soon celebrate the 50th anniversary. I think it's October, and it's worth visiting that test, which shows that organic carbon, the organic carbon stock goes down without pasture. But José, I don't know whether you know this, but in that test, there is the effect of pasture, but not of grazing, because those plots were not under grazing. This is what our group specializes in. Our group uses forage cover without grazing, and we compare that to grazing land. Pastures are great to increase carbon stock, but the grazing process is also important because it increases that value even more. So in terms of carbon balance, we do measure all gases. We have a very big project running in Brazil at the Federal University in Porto Alegre. There is a National Institute of Low Carbon Agriculture where we are measuring in all kinds of production systems, integrated systems, farming systems, livestock systems. But what contributes carbon is pasture. This is what the Uruguayan study showed. Number two, grazing intensity is key to know how much carbon we will gain, and the grazing method is not important. What matters is grazing intensity. Good grazing intensity, that is moderated intensity, that is not more than 60–65% of use of forage produced. If it exceeds that, then that will be too much. So if you have moderate grazing intensity, if pastures are well fertilized, there will be lots of carbon. This is key for a positive carbon balance. And if you have trees, then even better, because the value will go up, will go further up. And if you compare this to the specialized system, and this was a question I got, of course, you will not have so much a negative balance. The amount of methane produced per unit of animal product in the system has to be considered too. Though all those different elements in the system, but in general terms, a well-managed system provides lots of data. And we already have a lot of data that compare that these integrated systems are better than the separate systems. There is another question for José. What Paulo is explaining about grazing is a topic of a full presentation that took place yesterday. There's a question for José here. How do you see integrated systems in Argentina? Do you think progress is being made? Do you think those who are managing integrating systems are doing things correctly? What we are seeing is that there is increasing interest in the integration because of these benefits, because of what we're learning. It's still starting to take off. When we saw that some of the services could be maintained while more benefits were raised, that was a stimulus for farmers to start doing this. But on the other hand, I think it's more related to the social part. There is growing interest by the youth in seeing these integrations, in seeing that we can bring animals back to those fields and bring this foodscape concept, which is new, at least to me. So in short, I think it's growing rather slowly, but it is moving forward, and those who are working on this are doing things very well. Well, to close, two final messages. I think José and Paulo were very clear. The first question was, what are the keys for success? Well, to create a team that will help you move forward with a complex integrated system. You need workers, professionals. You need to know what skills these people need to have. And another important aspect is the grazing criteria. Paulo was quite concrete about this because it has a major impact on the final results. Thank you very much. I see there are lots of questions on grazing, whether it's grazing on pasture, on cover. Well, we will communicate and send these questions to the speaker. Thank you very much. Thank you, Paulo. Well, you missed the Malbec this time, Paulo.